Hi, good evening. My name is Mohak Chadda. I'm a final year PhD candidate at TUI Munich. Today, I will present a small project that I did called Modern Scalable Cloud Native CI/CD Pipeline. The different technologies that I have used in this project are GitHub Actions, ArgoCD, and Customize.io. These three technologies or tools together enable cloud native application build and deployment automation. In addition, I've utilized Terraform, Atlantis, and Policy as a code with Open Policy Agent. These three tools together enable infrastructure automation. I've combined these two aspects together using the GitOps methodology, which leverages Git as the single source of truth. If we look at the traditional CI/CD push-based workflow, a developer commits some code and creates a pull request in the application's Git repository. Following this, the CI/CD pipeline is triggered using tools such as Jenkins or GitHub Actions. This pipeline is responsible for testing the new code and building the application container images. In addition, the CI/CD pipeline is also responsible for deploying the built application container images onto the Kubernetes environments. So this workflow has some disadvantages. First, the Kubernetes cluster credentials are exposed in the build tool to actually be able to deploy the container images onto the clusters. This is not an ideal situation. Also, sometimes you need to open certain ports to enable the execution of commands. Another disadvantage is that the push-based mechanism is not declarative. What I mean by that is that you cannot specify what the end state should be, and there is no way for the CI/CD system to ensure that the particular state is maintained. For example, I want to have only two pods for a particular application. The CI/CD system will try, but cannot ensure that only two pods are present. However, the push-based workflow also has some advantages. First, it is easy to use and not bound to any specific tool. Looking at the new pull-based workflow, the developer commits the code to the application repository, which is either hosted on GitLab or GitHub. This triggers the CI pipeline using either Jenkins or GitHub Actions. The CI pipeline is again responsible for pushing the new images to the image repository, such as Docker Hub, Google Container Registry, or Elastic Container Registry. Following this, the developer updates the KS deployment manifest with the new image information manually or using something like Customize.io to do it automatically. So after you have updated the Kubernetes manifests, you want them to be part of the cluster itself. So that is where ArgoCD comes into the picture. It continuously monitors the repository for any changes, and if there are any changes, it synchronizes them back into the cluster. A similar tool to ArgoCD is also Flux, which is also part of the CNCF, which can be utilized. To briefly talk about Customize a bit, so what is it? It is essentially an overlay engine that enables you to create multiple configurations easily from a base version. Also, it has no templating language like Helm, because of which you can use standard YAML to quickly declare your configurations. So with Customize, you can easily have multiple configuration files targeting different environments. For example, if you want a specific number of replicas for a microservice in prod environment, this can be easily done with Customize using the replicas transformer from the same base manifest. So talking about infrastructure as a code automation, if you look at that, so the developer wants to make some changes to the infrastructure, which is also part of a Git repository. He does some changes and commits that code. Following that, the normal process which has to be followed by an admin is that he has to download the changes locally, run TF plan, look at the TF plan output, and then review and approve that, right? And then do TF apply to make the changes. But all of this can be actually automated using Atlantis. Talking about enforcing certain policies in infrastructure automation, suppose you are a company and you only want particular instance types as part of your infrastructure. Only want less than a particular number of nodes in your GKE clusters. These types of policies can be enforced and automatically checked using Open Policy Agent. So OPA allows you to write policies using a language called Rego, which are evaluated on the generated TF plan output. So if the policy checks passes, then it is forwarded to the admin to review and approve, and then it is automatically applied. And if it fails, then the plan is not available for reviewing. So all of this can also again be automated using Atlantis, using a tool called ConfTest, which is utilizes OPA under the hood. Right, so moving on to the demo. So in this demo, I mostly worked with Go Cloud Platform and GKE. I have followed best security practices such as service account impersonation and workload identity. Right, so there are two repositories essentially. One is this repository, which is called GitOps IAC, which holds the infrastructure files and also the policies. And there's another repository called GitOps application, which essentially holds the application code, right? So I'm mostly working with Knative here. So the application we're trying to do are functions. So essentially three different types of functions. So float, linpack, which is LU decomposition, and RN serving, which basically does inferencing on a RNN based model, right, using gRPC. All right, so suppose I have deployed a GKE cluster which is running Atlantis along with ArgoCD, and also has Knative installed with the different functions already deployed. Right, so Atlantis also provides this UI, which you can look at essentially to see what events are being generated, and this is what ArgoCD looks like. I mean the UI with the configured GitHub repository. All right, suppose I'm a developer, and so just to test it out, we can also see what is running currently. So if we look at what is there on the cluster, we can see what is there. Right, so we have ArgoCD deployed, Knative deployed, and also Atlantis deployed. Right, so suppose I'm a developer. Now I want to make some changes to this function, right? So currently it's normally you would do this using terminal, but just to make it better visually, so I want to make some change. Invoke function new just returns a different message when the function is invoked, right? So I will do commit and then create a pull request. Right, so I will do that, and then I will create a pull request. So right, so then it automatically triggers a CI/CD pipeline, and this is also triggered because the Atlantis configuration is done for the entire organization and not only the specific repository, but the configuration of the Atlantis Atlantis tool is not for this repository, so that can be done using atlantis.yaml. So this is not being checked here. So this triggers the pipeline, and if you look at the workflows which are there, so right, so this is just pull workflows which is being triggered when you do a pull request targeting main, right? And then what it does is essentially generates a new application container images and then uploads it to the Docker Hub. Right, so if you look at the pull request and let's wait for it to finish, right? So currently all these functions are being built again and pushed, but normally you can also do it only for the ones you have changed or modified. All right, so now all the actions have completed. Right, so then if you look at Docker Hub, you can see that right some the 3 new images were pushed, right? So let's merge them. To the main branch, right? So now if you look after merging, another action has been triggered, right? So what this does is similar to the previous one. It also generates the new application images, but it also updates the customized.io files, right, with the new tag informations of the updated images. So this is done essentially using the image transformer provided by Customize, right? So if you look at the directory structure, so you have the different base versions of the different function YAMLs, right? For example, if you look at RNN serving, so it defines basically what the Knative service looks like along with the base image and specific auto scaling parameters. But if you look at the overlays, right, so which works on the base version, it just changes the images essentially to the ones which are newly built. So after the workflow is run, these two information will be updated, right, and automatically then deployed onto the running clusters because ArgoCD is targeting that, right? So if we look at so still waiting, right? You can also check the logs for the different functions. Right. So now it runs another sub job, which is part of the main.yaml workflow, which basically updates the customized manifest, right, with the new tag information and the image information. Right. So now if you look at that, there is a new commit by the actions user, which just basically updates the Kubernetes manifest, right? So these are updated now with the new SHA version, which I'm basically using as the tag, right? Defined in the main.yaml workflow. So now if you look at sync, so it just updated that already, depending upon what it was, right? So it was syncing again and downloading the latest images to and running them on the Kubernetes cluster, right? So right. So let's just try to invoke the functions. So I have created a gRPC client, so which can invoke the function. So let's just try that. And this is the URL which you can get easily from the Kubernetes cluster, and invoke it using that, right? So now it shows invoke function new, which we modified accordingly as compared to the previous one, which was invoke function, right? So this is how all of this automation can be done. Now moving on to infrastructure and automation, demo of that. So if you look at this, right? So these are different Terraform files along with the modules and whatever clusters I'm using. So for example, I want to start a GCE instance. Let's try to start a GCC instance. So this is a module which does that, and let's try to start a GCE instance with E2 standard 2, for example, right? Let's just do that, right? So the developer wants to do that, so I will commit changes, right? So start GCE instance. Right, so then I will create a pull request, and then what happens is that Atlantis is automatically triggered, so it will do the Terraform plan for you, and then also do some policy checkings, but currently we'll look at this later. But currently we see that all policies have passed, and you can also see the output of the Terraform plan here, and then admin can also approve that, right, if he wants to do or change anything. So what I will do is, then I want to apply these changes. Everything is fine, so I will do Atlantis apply, right, and I will comment that. So Atlantis does this thing, and then it will trigger apply, and then in a few moments we can see that this EC2 instance has already been started, right? So if you look at the VM instance is currently running on the dashboard. We will see in a few minutes that it will start a new instance. Right, so right, so we see that it has already started, and if we refresh, it's created a new instance, right? Right. So now suppose I want to merge this now, right? So I started a new GC instance and then I merged it, right? All right. So now what I want to do is, for example, I want to change the type of this instance, right? So what I want to do is, for example, make it E2 standard 8, right? So I want to do this. So let's try that. Change GC. Right, so I will create a pull request, and so then Atlantis does this plan again. And then that does this policy check. Now we see that some of these policies failed, and not all checks have passed. So we see that this policy actually failed, right? So let's check the output. So it says that deny node type fails. So basically it says that E2 standard 8 is not allowed, right? So this is because we in this part of this demo I've implemented a policy which only enables two type of VM instances, right? So for example, if you look at the policy, only E2 standard 2 and E2 standard 4 are enabled. So you cannot create any other instance types, right? And suppose now I also want to do it for the currently running cluster. So this is the currently running cluster on GKE where ArgoCD and Atlantis are running. So suppose I want to do it for even for this, right? So I want to do 8 and I want to increase the number of nodes to 4, for example, right? So let's try that, and increase right. So I will again create a pull request. Right, so again Atlantis will do plan. Yeah, so sorry, so this has already been locked, so I think right, so I have to close this because I was stressing. Right, so let's do this again. So so it basically locks the state file, so you cannot do it again and again if a pull request is already modifying the state, right? So let's comment it again. So now it will do the plan and again check the policies. So now what we see is that two of the policies failed, right? So deny node creation and also deny the node type in GKE, right? So essentially these are again the two policies that I've implemented. So one of them does not allow more than 3 nodes in a GKE cluster and also only enables E2 standard 2 and E2 standard 4 types of instances on GKE or any compute instance, right? So that's it for today. Thank you for watching this demo.